Hey, so this is going to be a quick introduction to the templates lesson. Templates are basically generic functions, classes or structs that work with different types. Now one example would be when you create a container, what type of elements will it contain? So the objects or variables that are in that container, what type will they be? Integers, characters, floats, or maybe some user-defined types such as our entity or vector examples. As we'll see in this lesson, templates are used for containers from the standard template library, such as the standard array, which is a different way of doing an array by using an object. As I mentioned, with templates we can create more generalized or abstract code, but the code can get more complex because typically with more flexibility you will have more complexity, right? Also debugging the errors that pop up will be more difficult. As we've seen, we can overload functions to work with different types, but with algorithm abstraction what we want to do is we want to write a function that basically does the same thing regardless of the type of parameters or variables that it operates on. What's more, we cannot overload classes, but with templates we can make them more abstract, in that one member function that may have returned a type of integer can now return any type, an integer or a float, or a user-defined type, or it can have parameters of that type. And again, we can achieve this by specifying that class or struct to be a template, and then when we instantiate or construct that class or struct, we can specify the type. So basically your function or class or struct templates will contain a temporary type, and that will be replaced by the actual type that the programmer will specify. You can see an example of the syntax. Don't worry about this too much at this point. I will go over all of this in more detail throughout the lesson. This is just a preview of the syntax. You can see we specify a template prefix that is right before the function definition or prototype, and the same thing with the class or struct. We will have a template prefix, and that template prefix will tell the compiler, hey, this function or this struct or class is a template. The template prefix consists of the template keyword followed by a comma-separated parameter list between angle brackets. The comma-separated parameter list can contain type or template parameters or non-type parameters. We'll talk about the differences later on in the lesson, but the type parameter is basically a placeholder parameter, and that will accept or be set to the type argument that will be specified by the programmer when they invoke the function or when they instantiate the class or the struct. As you can see in this example, we have the type argument specification, where we invoke the print function template in main. We specify between angle brackets explicitly the type argument of int. As with regular functions, we can still have our comma-separated formal parameter list and our actual arguments as well. Notice with the instantiation of an entity class or struct in main, for example, in this case we have the type entity, that is followed by the angle brackets, and then we specify the type argument again, followed by the name of the object that we want to construct, in this case entity1. Another interesting thing that we'll talk about is that, just like regular function formal parameters can have default arguments, type parameters and non-type parameters can also have default arguments. Alright, so quite a few things to talk about in this lesson. This is just a first step, because some of the upcoming lessons will build on our understanding of templates.